if you have any suggestion, let me know. We're always open to dev, design, anything related to mobile. So with that said, how many people are the first timers for this meetup group? Let me just see a raise. Wow, okay, so about half, great. So welcome, and also welcome to the folks who were here before or come to our other meetup groups. Join all the meetup groups because we'll post different events at different places, so just so that you keep in touch. And then I also wanted to mention there's mobile and web DevCon coming up in July, and there's another conference coming up, Apps World, this month, and of course Google I/O is coming up. How many people, by the way, got ticket to Google I/O? Just wow, so almost less than. You got it? Cool. Less than 10 people. Wow. So well, if you're coming to I/O, I'll see you there. If not, sign up for mobile plus web DevCon. I was talking to these folks, and they were kind enough to give us some tickets. It's not available today, but at the next meetup, I'll raffle some tickets off for this conference. But if you can make time, try to come. We'll have excellent line of speakers. Richa is speaking there. And the past meetup, if you came to the one we did at Eventbrite on accessibility, where I spoke on accessibility, and where Juan spoke on app indexing, we're gonna have the same talks. Basically, I'm going to talk on accessibility at Mobile DevCon, and Juan is also speaking, and there's a whole bunch of other speakers. So check the conference out. I'll send a link to that afterwards in an email also. So with that all out of the way, today we're going to talk about architecture, and we have two speakers instead of one. So let me get the two speakers. So we, of course, if you don't know, this is Richa. She's one of our, meetup member a long time, and she was, she was brave enough to speak. So Richa is also an Android developer at Coursera, and before that, she worked at Amazon on Kindle Fire, and she worked on the voice assistant tool. That's really cool. And then she, on the Fire phone, right? Awesome. And then she also likes to automate her home, or hack, like program her home. So that's one of her passions. And then we also have our fellow colleague who joined, hands with Richa, and he's going to talk. Kevin is also an Android developer, and he is a recent grad from University of Waterloo, which is MIT in Canada, right? So really smart people today. And before we get started, I just want to, give a round of applause to the sponsors, everybody with the Coursera's t-shirts, Richa, Allison, and she said her mobile team, everybody who helped us set up the food, the logistics. There's a lot of people who go, behind the scenes. So let's give them a round of applause. And without further ado, effective Android architecture.
Thanks, Suyash. I'll just set up my presentation mode before we get started. All right, I'm good? Okay, all right. You don't see anything, right? Alright guys, let's get started. Suyash already introduced me. I'm Richa, and I'm an Android engineer at Coursera. And with me is Kelvin. He's also an Android engineer here. And we work on the Coursera Android app. The topic of today's talk is effective Android architecture. Today's talk is based on a true story. And Kelvin and I will be telling you guys about the architecture evolution at Coursera, the lessons we have learned, and the road ahead. Okay, this is better. I'm good. Brief introduction to Coursera. For those of you who don't know about Coursera, Coursera is an education platform with the mission to provide world's best education for free from world's top universities. The Android app for Coursera is available on Google Play Store. Do check it out and try some courses. If you have any feedback, please let us know. So the Coursera Android app has a large user base. Any bug in the app impacts hundreds of thousands of learners, some of them taking courses that are deadline-based. Building and releasing features is very fast-paced. We typically have 2 to 3 week release cycles. And we have a large user base in emerging markets. So some of the things that we really do care about is internationalization, providing offline access to learners, and handling spotty networks. All of this translates into the need for a very good, sound, and solid architecture. And good software architecture is not just important for good product quality, it's also important for effective collaboration in large teams. Some of the side effects of good software architecture that you will start seeing right away is common naming conventions in the code. Team conversations revolve a lot around architecture names that everybody knows about and can relate to. And code reviews just focus on the logic of the code rather than what classes you have in there, because classes are named around the architecture components in the app. A brief diversion here. The term good architecture always brings to my mind something that I want to tell you guys about. A few years ago, I visited Paris, and standing on top of Eiffel Tower, the view of the city is amazing. It's a beautiful city. In both directions, I saw buildings clustered together and then separated again by roads or highways. I figured out later that the city is functionally organized in exactly the same way it is visually organized. And that really amazed me. I find that example from the real world inspiring whenever I think about architecture in the software world. Coming back to the topic of architecture. With a show of hands, how many of us ever wrote an app with MVC architecture or something similar? How many had problems with MVC and had to look for better alternatives? So briefly, this is how MVC architecture is laid out. Like most of us, apps that I have worked on also started with MVC, and that needed to be rethought, as the app had to scale across more features or user base. And same was the story at Coursera. But instead of running around in circles and trying one approach after the other, MVP, MVVM, or others, let's take a step back and break MVC down. MVC was designed for GUI softwares for desktop and web in the 70s. These softwares had a very simple goal of just rendering data that was retrieved from the database that was usually co-located with the application. The story for the web and desktop softwares has also completely changed these days, but that's a topic of completely different discussion. Let's restrict ourselves to Android apps, and it doesn't map very well to Android apps too. Before we start talking about MVC more, let's model our architecture as a table of responsibilities. The architecture components in the columns and responsibilities of each of these components in the rows below them. With that, we will use this table of responsibilities as a reference. And as you can see, this table models the responsibilities of each of the components in a traditional MVC architecture. We all know that mobile is very different from web and desktop softwares. Some of the clear differences are that the Android platform closely controls the lifetime of application components. Activities, foreground services, background services, they can be killed anytime by the platform. Devices have a wide range of configuration changes that they can go through. The moment you rotate the screen, you have landscape mode, and then the views just need to be laid out differently. Most apps work with data that are provided by network APIs, and the apps themselves are not the primary authority of the data. The apps get the data, display them in the views, and then when changes are made to the data, they needed to be re-uploaded back through the network APIs. And devices have a bunch of sensors these days. Common ones are GPS, accelerometers, and apps most times have to respond to changes coming from the sensor data. Taking all of this and mapping them back to our table of responsibilities, this is what it would look like when it's updated. This is a realistic model view controller on mobile. Each of the components have more than one responsibility. More responsibilities in each component means more dependencies on the components that interact with them. For testing, this means having to mock out those interfaces. For testing any of the model or the view components with the controller, it means mocking out so many different interaction points with the controller itself that testing becomes a daunting task. I will briefly walk through what model view controller have typically looked like in the past when I have used that architecture paradigm in my app. Model would typically have methods to grab data from database or network, caching implicit if available. Views would almost always have this on-save instance state where it would have to save the current state of the view. And controller had everything that could not fit into the model or the view. So that also leads to a problem we commonly recognize as massive view controllers. So in a nutshell, MVC was defeating all the purposes that we as mobile devs at Coursera were trying to achieve. There was slowdown due to bugs. One change to fix something would break something else. Testing was becoming more and more difficult. So overall, all of these things users eventually start to notice as the app's quality starts to go down. So we really wanted to fix this problem and figure out the right way to do it. But the thought about what's the right architecture to use for an app that's trying to achieve so many different purposes does not come as an enlightenment. It has to be evolved with a lot of iterations and experiences and validating each iteration with well-formed approaches. So let's look back at our table of responsibilities that we laid out for MVC and use that as the starting point. It's very important to describe all of the responsibilities correctly in crisp and clear terms, a common software practice that I learned long time back, because these words will help us cues in solving this problem. All of the components in the architecture are handling multiple responsibilities. Do some of them handle responsibilities that may not belong to them? Do you spot the pattern? There are multiple components that interact with external agencies outside the app. Maybe it makes sense to move the responsibility of interaction in one place. If we just clubbed all of those interaction responsibilities together, we cannot fit them onto any component that we see in this table. So we probably need a new component to carry out all the interaction responsibilities. And we can call it an interactor. So this is what our architecture diagram will now look like. There is an additional interactor component in there, which sits between the controller and all the external agencies that the app needs to talk to. The controller will also have to forward events from these external agencies back. The interactor would also have to forward events back from system and model to the controller, so the controller can update view states or itself based on that. In terms of testing, just plain Java testing will work fine here because interactor is a plain old Java object. So this is our updated table of responsibilities. Controller looks slimmer by 2 responsibilities already. So we are making progress. Let's look at what can we reduce next. How about view states? And we see that the responsibilities are spread across multiple components, which is also not a good thing. Again, if we took both these responsibilities together, club them together, try to look around at our existing components, and try to fit them into one of the existing components, it doesn't make sense. So again, we probably need a new component to handle this responsibility. View model, that makes sense because we are trying to encapsulate view's state inside an object. And this is what the new architecture diagram now looks like. One of the good things about this is also that the view model, when pulled outside of these components, outside the view and the controller itself, can be updated outside the view and can be passed around between the view and the controller easily. In terms of testing, we already had this component that we could test. We now have this, our view, and our controller, which we can test easily. A good way to test views is Espresso. It's a really good library for UI testing in Android. And controller can be tested using Android test cases or other Android testing libraries of your choice. Mocking, almost always needed to mock out interaction points. Again, going back to our table of responsibilities, it's quick to note that the controller is not doing any controlling anymore. It's just handling view events and updates to the view model, navigation in addition to that. So in a nutshell, it's just handling view's presentation logic. How about we change its name and then give it the right name? Let's go with presenter. And then update our table of responsibilities. If we again go back to this table and start looking at the responsibilities under each of the components, there's still some interaction logic lingering around in the model. Maybe we can combine this into interaction with data rather than thinking about where the data is coming from and move that into a data source layer. And then we just worry about the use cases rather than worry about how do we grab the data, do we grab it from the network first, do we grab it from persistence first, how do we cache it. That all goes into the data source layer and which can be implemented independently as a repository pattern using different approaches to that. And that's a completely different discussion than building features. So in terms of testing, we had these components that we could test with different testing approaches. Now we have one more component that we can test for just its use cases. And again, some Android testing will be needed there. Again, use a library of your choice for testing out that layer. Going back to our table of responsibilities, it's good to see that now each of the component in our architecture has only one responsibility, except the presenter. And it's a little difficult trimming it down right away because it sits in the middle, it handles all the interactions from the view and handles interactions from outside the view. So one of the things that we can immediately identify here is navigation. Typically in Android, this is start activity or start activity for result, things like that. So maybe we can again have a specialized component that handles the navigation across the app and call it a flow controller. And now again, we update our architecture diagram based on that. So the flow controller now sits on top of views, and it acts as the gateway to launch activities inside the app. Adding activity transition also becomes super easy with this. Imagine that you wanted to change the way your activities transition in your app. And you would normally have to go in 10 different places and change the activity transition logic. If you use a flow controller, you can just change it in one place and done. In terms of testing, again, it can be tested using Android test cases. So here is our final table of responsibility now. We can easily club together the responsibility of handling view events and updating view states because they kind of go together hand in hand. And we achieve this objective of really figuring out which architecture can help us separate all the responsibilities in the application when we are building a feature, and how do each of the responsibilities look simple enough that can be implemented by a single class. So here is the updated architecture diagram again. But there's still one problem in the architecture that we just arrived at, which is the flow of arrows in both directions. That makes it extremely complicated to make changes to one component without affecting others, because there is a lot of strong coupling between each of the components. But if we look closely at this diagram, the dependency of the presenter on the view, the interactor on the presenter, and entities and system on the interactor, they're not really synchronous calls between each of them, and they can be replaced safely with notifications as callbacks or observables. So we just apply dependency inversion to our architecture and we can achieve that. Before going further, just describing what dependency inversion means, it's one of the 5 solid principles, and it advocates that components in the architecture of a software system should be decoupled. Typically, the higher level software layers should be decoupled from the lower level software layers, so that in a typical app, you can change views without affecting the database. That way, you can just add another field into your view without going down all the way to the database and making changes there.
Hello.
So we can remove the strong coupling and replace them with these dotted arrows that denote loose coupling. And the strong couplings, we just replace them with notifications as callbacks or observables, or whichever other mechanism you think fits your needs. So this architecture is not something that we entirely came up with on our own. There have been inspirations from some of the Viper architecture stuff done at Mutual Mobile. And we kind of looked at different architecture approaches, tried to figure out if we had to do this, would it make sense to us? And then arrived at something that's a modified version of this Viper architecture. So we started from MVC, and we drilled down all the way till we arrived at an architecture that looked like solves most of our problems. But what validates it? What makes us feel that this will work without even writing a single line of code? We obviously don't want to go off and start building our features based on this architecture and then figuring out it doesn't work and let's go back to the whiteboard once again. So common approaches that work in these cases is to look at well-established software design principles out there and validate our approach against them. Solid is one of such widely accepted principles. A little bit about solid principle. It is a set of 5 principles that have been proven time and again and advocated to be able to use to build flexible and extensible softwares that are able to stand the tests of time. We did not validate against all the 5 principles. We talked among ourselves as a team and tried to figure out which are the top ones that make sense to us. And we particularly cared about the single responsibility principle, which means that each component in your architecture should ever have a single responsibility that you can take and implement as a single class. Interface segregation principle, which means that you should always program to interfaces and then change implementation as and when you like. And dependency inversion principle, which means that the higher level software components should be decoupled from the lower level software components so that you can change the components that need to change more often without having to change the components that need to change less often. And following solid leads us to clean architecture. What I really like about clean architecture is the dependency rule that they define, that you just follow this dependency rule and things will work out. So mapping back the clean architecture layers to the architecture that we were just looking at, we can divide our architecture into distinct layers also. So there is a distinct UI layer, which consists of view, presenter, view models, and the flow controller. The domain layer or the use case layer, which defines the use cases for the app, just consists of the interactor, and sometimes the system component, and the data layer contains the entities. So this architecture has been working out really great for us, and Kelvin is now going to take over and talk a little bit more about how do we implement it in practice, what are some of our key takeaways, and a demo.
So here's some of the practical experiences that we've learned when implementing Viper on Android. Well, this is how navigation works. Our app is comprised of a bunch of different modules. Each module will have its own activities with content and its own feature. For example, catalog or quiz or video. We have a shell app, the application module. It's just a shell. It's an activity. It has no activity of content in it. So basically, the shell app decides which activity it launches on startup. Navigation between our components is based on deep links, so our features will register their main activity with the shell app. So when one feature needs to navigate to the other, in our example, the catalog to video, our catalog module will provide the video feature URL to the shell app. Then our shell app will give an intent back to launch the video features activity. With view models will have to encapsulate our view states. So that means, say, if our device is rotating or backgrounding, we need to save and restore our view states. How we do this is either with retainable fragments, or we make a parcelable and we save it to the activity bundle in on-save instance state. If we wanted to make a parcelable, it's a little tedious, but if we have auto parcel, it comes in pretty handy for that. The chain of responsibility kind of looks like this. So with the dependency inversion, we decouple our outer layers with the inner layers. So this way, when we make calls from the outer layer down to the inner layer, we subscribe to the results. This way, our inner layers, like from the network, it publishes results or errors in response to what we wanted to do. So this way, with our chain of responsibility, so any layer in between, like the outermost or innermost, we can capture these events as we pass them up and down, and we can either continuously pass them up or process them as we see fit. So adopting clean architecture in practice isn't really as easy as you would think. In big teams, there's a lot of teamwork issues. So there's confusions and discussions and arguments whenever you try to implement these things. But if you're a team, you just you learn as you go, and you eventually work everything out. So some drawbacks with implementing Viper is that dealing with context. We have so much context that we have no more context about the context anymore. This is horrible. This is pretty difficult to understand, but I think with time and experience, it gets a bit better. Viper is tedious, can't deny that. It's not always clear at the beginning to understand all the components and each responsibility that it has. So that's always going to be cases that are confusing and a bit muddied and not sure where to put it. So what helps with that is referencing design principles. So each feature, as we see, needs at least 7 classes, and it's tedious to create and test. But with some proper brainstorming or with smart reusability of our classes, that can cut it down quite a bit. Finally, Viper is, I'm not sure how widely adopted Viper is compared to, say, Model View Controller, but it's definitely pretty hard. When I first started, it was super confusing for me in figuring out where everything should go and why we broke everything down as was. Some key takeaways from this is that we should just ship the latest ideas. So unless we have something out there in the real world with the architecture that we came up with, there's no real confidence in it or validation in it. We don't know if it works or not, because if we're just testing it on our own, we're not the end users. We don't know. We might not be the end users, so we don't know if it's going to work or not. Code refactoring, it's a mess. It's always tempting to kind of refactor legacy code, but it's a rabbit hole. So anyone who's tried refactoring would know, you have no idea how deep it's going to go. So one thing that has worked for us is that we just refactor the features that are getting new design changes, and other times, situationally based, it's better to just refactor the whole thing and just accept that you're going to lose a week of time. Validation, it's just the best way to see if your code will work or not. So for example, with proper tests, you can see if you've properly broken everything down. And by using Viper, any new feature you make is going to be a lot faster and less error prone, and you're going to have a higher quality of a product overall, just because you know where everything is supposed to go. And really, you have to iterate. So the first version of any idea might not be the best one. It gets turned out horrible. So every iteration is an opportunity to learn and improve. So it's almost impossible to write the perfect software, but with each iteration, it gets a bit better. And with the difference between each iteration should get a little bit smaller and smaller. We have a small code demo. So you can find the source code at that GitHub link. And what it does is it just pulls a list of Coursera's courses and it puts them in a scroll view. So some of the main classes that we need to look at, these are the typical classes and a new feature that we would write in architecture. So we would typically implement everything else down there besides the main activity, sometimes more, sometimes less. It really depends on the feature. But there's some main things to look at that do follow the Viper architecture. For one, our main activity has no content in it. So it just calls the flow controller to launch the proper default launch feature for our app. In the future, if we ever want to, say, change default feature or do A/B testing, it's really easy to change it just right here. We have a flow controller. So the flow controller for the catalog feature knows how to launch the activity, which displays the catalog and its launch mode and other details. So you can see with the intent, you can add a bunch of details in there and change it as is. We have a catalog activity. So the catalog activity is responsible for creating the presenter and asking for the data it needs to display. It does that right in the onCreates because we only need one presenter. And in onResume, we subscribe to the updates to the catalog from the presenter. Again, this provides a logic for handling the results being the catalog. In onPause, we unsubscribe to our updates for our presenter. We just don't want any actions to be triggered as a result of the subscription when the Android lifecycle kicks in, so for example, if the activity is about to destroy it. So we have a presenter, and in here, it creates the view model and the interactor. So since it acts as the bridge to the view and the view model, and updates to the view model are only made by the presenter and not by the view. Here we create the view model, the interactor, and we decide to load the catalog. And in here, our interactor, we get our courses from the interactor, and we subscribe to the actions here. And when we get the list of courses, we can decide to do what we want with it. So the presenter also provides the hooks to the activity to subscribe and unsubscribe to the catalog updates. Again, we don't want to do it during weird states of the Android lifecycle. The view model, in turn, provides hooks to the presenter to subscribe to the view model data. So in our case, we use RxJava to implement reactive updates. And so view model data objects are RxJava subjects that we can subscribe to directly. Finally, we have an interactor that grabs data for this use case from the data source. So our data source could be a network or from the database. So this detail is hidden from the interactor. It doesn't care. It just grabs the data. There's no reverse path anywhere here, and this is the loose coupling concept that we talked about earlier. So here are some libraries that we use in our main app. So one of them is RxJava. So the RxJava is great to use for the observer and the chain of responsibility pattern. So we subscribe to the observer. Dagger is the best solution for dependency injection. In particular, we use Dagger 2 for our main app, but in our sample code, you'll see it's Dagger 1. And finally, retrofit is a great way to write down REST APIs as declarations, and it integrates really well with RxJava, which is perfect. So the final takeaway from this is that architecture isn't static. So if functionalities change, then our architecture probably needs to change too. So that's why it's important to have a well-formed approach to this, to understand our changes and to change accordingly to this. So if you liked everything that you saw here and you want to work with a cool team here at Coursera, and if you believe in our mission, then please send us your resumes because we're hiring. Are there any questions?
Let's pass the mic around so we can capture it in the video. Thank you. And introduce your name if you want to.
Alex Bravo. You mentioned that there are 7 classes per component. Are they all required, no matter how big or small is component? Still all 7 are required?
That's a good question. For most features they are, but there are some features that we build sometimes which, for example, don't require updates from the network or the database, or don't require updates from external agencies. And in those cases, we don't need some classes. So give or take a few. In some cases, we may need more to build, depending on the feature that we are implementing.
Hello. I am evaluating RX Java myself right now. From what I've read online, it sounds like there might be some issues as far as testing goes. It can be a little complicated. Have you guys run into any of those problems with your app?
RX Java for testing, if you have proper mocking in place, you wouldn't even need that. So we normally don't call RX Java directly. If you see that, we have that hidden inside a value object. So if the view model is mocked out, then we don't even need to use RX Java in our testing anywhere. It will be hidden behind the mocks.
I would add on to that. Check out Juan Gomez's talk. He works at Netflix, and they are the pioneers in the RX Java, and he did a really good talk about explaining what it is and how to use it in your Android projects. Any more questions?
Swish.
During your architecturing model, you kind of normalize to make it like cleaner design. But you never mentioned about the performance trade-off. How you guys adding the performance trade-off on your designing model?
So performance doesn't necessarily go with breaking down the components. All we are doing is defining clear class hierarchies and which layer handles what. In fact, it becomes easier rather than harder to figure out where the performance bottleneck may be. So if you push down everything down to the data source layer, you can actually test the data source layer independently and see how, using integration test, how fast is the network. When it comes to testing the UI, there are different approaches, like you can use hierarchy viewer and stuff. You can turn on settings in on your device to figure out if you're doing overdraws and stuff. So those things can be tested independently. One of the things is what happens when you're doing stuff on the UI thread, and how do you figure that out? Again, because you have things separated out in your data source layer, you just look at this layer, all of this layer, and when you see those white gaps, if you use DDMS for debugging, if you see these big slots of gaps on the UI thread, you can almost always figure out where it's coming from. And if it's coming from this layer, you can test both the layers independently. If it's coming from the layer in your feature, just like go through those 7 classes and figure out where you are not pushing things to the background thread when it should be.
So I had something I wanted to mention to Calvin. There were two things that perked my attention. He said, A, there's a complexity there to actually learn your software architecture. And secondly, he said there wasn't a good way of knowing if everything was working. And I thought, well, the right thing to do then is use your app and build a class that teaches the organization. And so you'd actually be then teaching and using something. Just a thought.
Yeah, to add on to that, I think the talk was great. it would be nice if people can have some code sample, like maybe your demo app up, so they can see how to implement the architecture.
It's on GitHub.
It is on GitHub already.
Yeah.
Perfect. So
it's on GitHub right now. The link is in the slides. So
Awesome.
I'll post the slides on speaker deck and send you the link, and you can share it with others.
Right.
The code sample does not cover all the complexities of our full-blown app, because we didn't want to make the sample complicated and difficult to follow. But just look at the sample itself, and it has all the things that we talked about in our code demo.
Perfect. I have one question. How did you, so I don't know how many people work with you on Android, how do you guys divide the responsibilities, and how do you now, so that you have really good structure in your code, how do you guys divide and conquer the work?
Sure, that's a great question. One of the great things that we get from this architecture is these clear separations. So we can sometimes define the separations between the UI layer and the data layer. The UI layer is typically the view, the presenter, the view model, and the data layer is the interactors, which is talking to the network, getting all the data, and also handling system events and stuff. So if we have two people working on a feature, we typically divide it by sometimes between UI layer and data layer, and then one person just develops the interactors and tests them using unit tests, and done. The other person works on the UI layer, develops the different layers, tests them, unit tests them, done. And then they just integrate with each other. We can look at our unit test itself to figure out if our assumptions in each of the layers are correct, and we can fix them without even integrating directly. So that gives a lot of decoupling between the team itself, and then we can switch roles on another feature. So instead of one person working on an entire feature, we can also collaborate on features. If we also want to break down the UI layer further, again, the presenter, we are always programming to interfaces. So one person can just work on the presenter, unit test again, and the other person can work on the view, and again, write the unit test.
How do you handle the difference between Kit Kat and Lollipop?
That's a good question again. That's a question outside of the architecture most of the time. It may mix with the architecture as well. The differences between Kit Kat and Lollipop sometimes is from the themes that you're using, like Lollipop requires app compat and stuff. Other times you can, you have to look at the, so support libraries are great. They help you, if you just use support libraries most of the time, you don't have to handle the differences. Other times when you do have to handle the differences, you can look at the API level that you're using and figure out which feature to launch in each of the cases.
I had a question with the save instance. So how do you manage the save instance between the Android app and the web app, so at the architecture-wise?
On save, I don't follow your question.
Like the save instances, for example, like you are in a save state in your course somewhere, you're paused somewhere, and then you open it up in the website from the Android app.
Mm-hmm.
So how does, like, do you have like a single interface which has two different implementations? How does it work?
So that is not related to on-save instance state. So on-save instance state is particular to an activity. So when you are inside of a view, and you just launched another activity after that, and you want to come back to this view, how does this view remembers the state it was in? In terms of how states are saved between the mobile app and the web app, it's independent of that, but then we do figure out ways to make sure we are synchronized between the two states, like course progress and stuff. That's again independent of architecture, but we do have some logic about when do we reach a point in the app when we want to save the state. So for example, when a video stops playing, we send an event to the web saying that the user has watched this video. So when the user goes on their account on their laptop, they can figure out, oh, I already watched this video on one of my devices, and I can start from watching another video.
Who else has a question?
Can you talk a little more about how you use Dagger, how you break your app into components, and also why did you switch from Dagger 1 to Dagger 2?
Sure. So the way we use Dagger is we have an app-wide component where we initialize network clients, clients for where we get overrides for A/B testing, clients which we use to record metric events, initializing REST adapters for retrofit and things like that. So that all usually belongs to the application component. Then there are activity-specific components or feature-specific components, like we talked about this whole 7-layer structure that's implementing catalog use case. So we have a catalog level component where we define, where we inject the catalog activity and other catalog-specific components. Sometimes there are singletons like catalog interactor, which again needs some initialization, again with the A/B testing client and other stuff. So there is usually 3 levels of components: an app-wide component, a feature-wide component, and view-wide component, which is usually the activity. One of the things we really like about Dagger is that context mesh that we were just talking about. By defining scopes in Dagger, we at least can figure out whether in the content provider we need the application context, and on anything that deals with the views, we know that we just want the activity context. And we can pick the right one without having to second guess what is being passed to us, and if we use that, are we going to run into problems?
Anyone else with a question? No?
So for each feature, you're saying that it has those 7 components. Do you ever have a situation where like you have 2 features that use something similar that can be shared? Like, so how would you share the components with another feature?
Sure. So we do have those situations sometimes, and what we then do is move them to common modules. So for UI, we have one module where we have common views that are shared across multiple components, like a course cell, which can be just defined in one place and used in other places in the app. We a lot of times have cases where we share interactors between different components, and in those cases, again, we put them into a common module. Usually the shell app depends on something called a core module, where we store all of these things, where we store all our eventing libraries, things that are used throughout the app. So that's where we put them then.
Any more questions?
Can you talk a bit more about your testing framework? What libraries you use and how do you use it? I saw Espresso there. You also use RoboElectric?
RoboElectric, we do use RoboElectric, but a lot of times we have issues with RoboElectric. So in my past experience, I have been really happy using instrumentation tests and Android unit tests. So sometimes you just switch to that then, because it makes life a lot easier rather than having to debug configuration problems with RoboElectric. Are you good?
Questions? Ask away. We have time.
Cool. Silence. All right. Great. Thanks a lot. Hope you guys enjoyed the talk. If you have any questions later, feel free to ping us on the Meetup chat group. And I'll be posting.
Emails are up there. And
Yeah.
is up there.
Yep. LinkedIn is up there, Twitter is up there. Again, we are hiring, so if you are interested in interviewing with us and figuring out a fit, feel free to email your resumes. And other than that, have a good night.
I just wanted to give a few minutes, because sometimes people want to make announcements. And also, I emailed everybody, if anybody has lightning talk they want to present today, we can do it. We have some time. If anybody want to do a quick lightning talk, if they want to show us something or talk about something, a minute would be maximum. If not, if you just want to make an announcement, if your company is hiring or if you're looking for a job, don't be shy. This is the platform, everybody's here. So come over here on this side. And if you have any announcements to make, so feel free to come over. I know a few people are hiring. So nobody wants to. Okay, good. People are coming. Don't go away right now. We got a few. By the way, I did not hit the gong. I was supposed to hit it before we started this thing, I guess. So we'll just do it right now. I don't know Kung Fu, but...
My name is Jaya Panda, and I'm looking for like entry-level developer position in Java, Python, or Android development. Right now, I work for Cisco system as a network protocol test engineer. So, if anyone is hiring for entry-level position, please let me know.
And contact, just stick around here for a little bit.
Yeah, my contact.
Your contact information. So here is something I don't like. Don't put it on Meetup because everybody, recruiters and whoever, like you can get spam. So if anybody's hiring Android or Java engineer, she's available. So just stick around here, and people will come find you.
Hi, my name is April Wenzel, and I work for a company called Cognoa, and we're working on an app to assess autism and other developmental delays in kids. I'm the back-end developer there, and I do some web front-end as well, but we're looking to hire some Android engineers. So if you want to help little kids and their parents, and you're an intermediate to senior level Android developer, come talk to me, or email me at april@cognoa.com. Thank you.
Do you want to quickly say your email address?
It's jaya.panda@gmail.com. J is in Jack, A is in Apple, Y is in Yellow, A is in Apple, Paris, Apple, Nancy, David, Apple.
At Gmail. At Gmail. And everybody, I'm sure people know this guy, right? He spoke before, and we want to bring him again and speak again, and they have also hosted our meetings.
Yeah, hello. My name is Tony Constantinidis. I'm a CEO of a company called Constant Innovations, Inc., which is my own company. I specialize in building SDKs and also anything to do with multimedia streaming. Extremely good, and if you have a bottomless pit of money, come talk to me.
Hi. I hope you don't mind I'm promoting my app here. Okay, that's great. So before I promote my app, may I ask you a few questions? So first is, how many of you come here and you want to know more people today? You want to connect with more people today? Can you raise your hand? Okay, there are many. I assume all of you want to know more people here because we have some common interests. So the second question is, how many you think you can get to know today? Or how many you already know today? 10? 5? Okay, so but we have almost maybe more than 100 people here. You only know 5? What about the rest 95? You just missed the opportunity. Because next, CEO of next Airbnb may sit here, right? But you just missed the opportunity to know him or her. So that's why I created an app called MooChat, M-O-O Chat. With the app, you can download the app, and you don't need to sign up or log in. And I have created a chat group with the passcode, which is 0508 is the date of today. And you just input their passcode and choose a name, what do you want to be called. And everybody here can join the same chat group. So you can, in the chat group, you can post what you are looking for, like here we are talking, or you can ask questions. If the organizer in the chat group, you can connect the questions to answer. And even after the meetup finished, you can still communicate in the chat group. So basically that's it. Let me repeat again. It's MooChat. It's available in both Android and iOS. I actually launched it last week. And today's chat group, the passcode is 0508. If you use that passcode, you can use the same chat group. Okay. All right. Thank you.
Local Twitter. Okay, cool.
My name is Greg, and my app is a little less it's more boring than that one. I'm trying to build a scraper. I deal in precious metals, gold and silver. A lot of Indian and Chinese clients, by the way. But anyways, I'm trying to build a web scraper, or excuse me, a price scraper for iOS and sorry, and Android. And my sister's a doctor here at Stanford. She's building an app too. So anybody that's superstar, give me a holler. I have business cards here, so you can get my email that way. Right? Thanks.
This is open to iOS. We love iOS.
Yeah. So
when I do Android meetup, then I don't. But
well, my sister's app, she must do it on her iPad. Okay. And it doesn't have to connect with Epic, which is a nightmare. Anyways, we can talk. Okay. Cool.
Hi, my name is Peter, and I'm with a company called meetup, and we're doing what every developer hates, me myself included. It's testing. You probably all hate testing, even though it's probably the most important part. And testing on Android is a nightmare. I've done this myself. I know it's a nightmare when you need to test on multiple devices. And what we're doing is we're building a device cloud where you can upload your APK, and our smart monkey in the cloud will test your app on multiple devices we have connected to our servers in Latin America, likely. And you will get a video feed of all the monkey does, of all the monkey clicks and taps and swipes, and everything that it would do with your app there. We're in beta right now, and we need feedback from Android developers, because we're Android first. We need feedback from Android developers who have ideas on what an ideal testing environment for Android is. So if you have any ideas about this, feel free to drop me an email. I'm Peter S-P-E-T-E-R @monkop.com. Monkop as MONKOB.com. So if you have any ideas what an ideal testing environment for your Android app is like, shoot me an email. You can test our beta version online right now. You can just upload your APK and get one device tested. Thank you.
Thank you. Quickly.
I have a question.
Question?
Can we use the device also?
Not right now. Right now, just get around one.
Okay, thank you.
All right. So we have a few minutes, I believe. We will spend about 10-15 minutes here wrapping up. Feel free to meet the rest of the people. And otherwise, we'll see you in June. Thank you very much.